Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ukobela Maths. And without any further ado, let's look at this question that we have here. Okay, so we have question 4 on momentum and impulse. It says a wooden block of mass 150 gram is freely supported on brackets at a height of 2 meters when a bullet of mass 50 gram is fired vertically into the block as shown below. So this is a question that has been extracted from your 2024 prelim paper, Gauteng province, right? So it's just been written recently. And then as we can see here, the one thing that you needed to note, guys, in physics paper 1, we never have our masses in grams. So always our mass needs to be converted to kilograms. So that's the catch right there. You needed to first convert the 150 gram and the 50 gram to kilograms. Remember, paper 1, we deal with mass in kilograms. Then paper 2, chemistry, we deal with mass in grams, right? So it's very important that you note the difference. Paper 1, if they give you in grams, you need to convert to kilograms by dividing by 1,000. But then in paper 2, if they give you in kilograms, you need to convert to grams by multiplying by 1,000, right? So here below, they say the bullet embeds itself into the block and the bullet block system rises vertically into the air for a few seconds and then falls back to its original position. Then 4.1 says state the law of conservation of momentum in words. So easy peasy, 2 marks right there. So just know that your definitions can amount to something like 20 marks in a full exam paper. So make sure that you enter the exam room knowing all your definitions for paper 1 if you're going to write paper 1, and then knowing all definitions for paper 2 if you're going to write paper 2, right? Then 4.1, the law of conservation of linear momentum states that the total linear momentum in an isolated system is conserved, or others might say it remains constant, right? So the total linear momentum in an isolated system is conserved or remains constant. So 2 marks just like that. Okay, then now we have 4.2. It says calculate the magnitude of the velocity of the bullet block system. Note that the bullet block system after the bullet becomes embedded in it. So now if we are to calculate this, we know that we do not care whether this is an elastic collision or inelastic collision, because in both these collisions we know that the momentum is conserved. So we can start by saying sum of momentum initially is equals to sum of momentum finally. So this is before and after, right? But then which case is this? This is a case whereby the objects were moving separately and then they become a unit, right? Because remember, they say that the bullet will embed itself in the wooden block so that it becomes a bullet block system. So now, initially, the two objects were moving separately, but then finally, they now move together as a unit, meaning they have the same final velocity. Right. Now, what is our mass? We are not supposed to substitute 150 gram. We are supposed to substitute 150 divided by 1,000. That's equals to 0.15, right? And then the velocity initially, a wooden block of mass 150 gram is freely supported. So it is just stationary there. So it has a velocity of 0. And then mass 2, that is of the bullet, this will be 0.05. And then we are told that it has an impact velocity of 200. And then is equals to, now we have to add the two masses since now there is system. And then we are looking for the final velocity. Now, obviously, when you punch this into your calculator, this is 0. So that means we're just going to do 0.05 times 200, which will give us 10, right? And then this side up, when we add these ones, this is 0.2, and then VF, divide both sides by 0.2, and then our final velocity is supposed to be 50 meters per second, right? And then they said magnitude of the velocity, so we can indicate that it is going upward. So, but then it's not necessary. Okay, 4.3 now they're asking, is the collision between the bullet and the block an elastic or inelastic collision? Explain by using a calculation to justify your answer. Right. Then for that one, this is what you need to note, guys. It is very incorrect to start by doing this. EK initially is equals to EK final. So this is a big no. This is a big no. Why? Because we haven't concluded, right? We are still trying to conclude whether it's elastic or inelastic. So this already concludes that this collision is elastic, right? When you start by doing this, you've already concluded that the collision is elastic. But then here we are still trying to prove whether it is elastic or inelastic. So the best way to tackle this is to calculate your sum of EK initially separately, and then also the sum of EK final. And then from looking at the values, you can then conclude whether it's elastic or inelastic. Elastic if sum of EK initially will be equal to sum of EK final. Inelastic if they are not equal. Right, so this is how you are supposed to correctly tackle that question. So you will indicate sum of EK initially, and then you'll say this is half mass 1 V1 square plus half mass 2 V2 and then square, right? So mass 1 we will take it as the wooden block, and then mass 2 will take it as the bullet. So half, we have our mass at 0.15 for the block, and then the velocity of the block initially was 0. And then here we have half, 0.05, and then the velocity of the bullet initially was 200, and then square that. Now you simply just grab your calculator, punch all of that into your calculator, you get 1000 joules, right? Now, separately, you calculate EK final. And then again, this is half. But then remember, finally, they become a system. So I can just go M1 plus M2, and then they will share the same velocity finally, square. And then this is half the mass 1. So let's just add them together. When we add them together, they gave us 0.2. And then what was the final velocity? We did calculate in the previous question. It was 50. So 50 square. And then when you punch all that into your calculator, you get 250 joules. Now from here, that's when you can conclude. So at this point, we can say, therefore, the conclusion that we see is that EK initially is not equal to sum of EK final, which means that the collision is what? Inelastic. Inelastic. So this is an inelastic collision. Right. Okay, then done with that, 4 marks in the bag. And then we have 4.4. It says, on a different occasion, a bullet is fired closer to the wooden block at the same velocity, and it exits the block with an upward velocity of 195 meters per second. Right. If the net force exerted by the block on the bullet is 5 Newton downwards, calculate the time it takes the bullet to exit the block. So this is based on the bullet. So we know the formula that we have to apply is the impulse momentum formula. So the impulse momentum theorem, which says the impulse of an object is equal to the object's change in momentum. This is the one that you can just, after all, play along, and then sometimes you find it written as F net is equal to change in P over change in T. This is when you are having your Newton's second law based on a momentum, right? But then the original formula from your formula sheet is like this, right? Okay, so we are given that F net is 5 Newton downwards. So let's indicate here that we'll be taking upward as positive. So up as positive because even with this question here, we assume that up is positive. So let's just continue with that. So if now they're saying this is 5 Newton downwards, therefore I understand that the 5 Newton here would have to be a negative value. So this is negative 5, and then we have delta T. And then I need to break down the change in P. So that's mass V finally, V initially. So I have negative 5 delta T. So remember, we are looking for that time. Calculate the time. And then the mass of the bullet, right? So this is based on the bullet, 50 gram, which we did convert to 0.05 kg. And then what's the final velocity? Remember, this is a different occasion. So the final velocity in this case, it's 195 upward, right? So it moves upward with a velocity of 195. So I'm just going to substitute the 195 as a positive, right? You would substitute it as a negative if you took downward as positive. Then minus VI. So the initial velocity, remember they said on a different occasion, a bullet is fired closer to the wooden block at the same velocity. The same velocity they're talking about is this impact velocity, 200. So then we have 200 here. And then obviously to find our delta T, we need to divide both sides by negative 5, right? And then now our delta T is equals to, punch all of that into your calculator, you will get 0.05 seconds, right? That's how you were supposed to tackle that question for a total of 13 marks. So it was a pretty easy question to deal with, nothing much complicated there. You just need to brush up on your momentum and impulse notes just to tap into those formulas and understand how to apply them. But otherwise, it was a very fair question. Right, so with all that being said, please press the thumbs up button if you have enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning SAT.